Welcome to Math Vision tutorial. My name is Moses. Today we shall be talking about the extremum values and the extremum point of a function. But before we talk about the extremum values and the extremum point of a function, we need to consider the domain of a function. Now, remember that a function can never make sense without its domain. So, what is the domain of a function? The domain of a function is simply the set of inputs or the set of numbers that is generally accepted by the function. Suppose we have a function f of x to be equal to 2x squared plus 1. What is the domain of this function? The domain of this function is the set of all numbers. Why? Because for every real number you pick and put into this function, you will be able to evaluate this function. For instance, let's consider the set of 1, 2, 3, 4, 5. Yes, this set of inputs is accepted by this function. Why? Because if you evaluate this function at the point where x equals to 1, you will get a value for this function. If you evaluate the function at the point x equals to 2, you will have a value for the function. If you evaluate the function at the point where x equals to 3, you will have a value for the function. Also, the set minus 2, minus 1, 0, 1, and so on. This set also will satisfy the domain of this function. Why? Because we can evaluate this function at every point in this set. So this set satisfies the function as its domain. So the set of all numbers satisfies this function as its domain. Why? Because we can evaluate this function at every point of x, which is the what? Which is a real number. So now let's consider another function. Let's consider a function f of x equals to x over x minus 1. Now we want to know the domain of this function. We know, how do we know the domain? We said the domain is the set of numbers or the set of inputs that is generally accepted by the function. So now, the function will accept all numbers except 1. Why? Because putting 1 in this function, we will not be able to evaluate the function. We won't have a result for the function. By evaluating this function at the point where x equals to 1, we are going to have this to be 1 over 1 minus 1, which will lead us to 1 over 0. And 1 over 0 cannot be evaluated. 1 over 0 is not 0. 1 over 0 is undefined. Press 1 over 0 on your calculator, you will have it to be syntax error or math error. We cannot evaluate anything over 0. We can't evaluate 1 over 0. So we call this undefined. So the point that makes this function to be undefined is the point at which x equals to 1. So we must avoid 1. That means this function does not accept 1. So the domain, the set that will satisfy this function as its domain must not contain 1. The domain of this function is the set of real numbers. That is all numbers except 1. So we write it as this. This is the domain of the function. Example of this is the set of 2, 3, 4, and so on. Example of the domain of this as well is the set of minus 3, minus 2, 0, 2, 3, and so on. These are the sets that satisfy this function as its domain. So now, since we understand the domain of a function, that a function can never make sense without its domain. For a function to be, there must exist its domain. So now, what is the extremum value of a function? The extremum value of a function is simply the maximum value or the minimum value of the function. Maximum value of a function is simply the highest value of that function in its domain, while the minimum value of a function is simply the lowest value of that function in its domain. Now we want to talk about the extremum point. Extremum point is simply the maximum point or the minimum point of a function. What is maximum point? Maximum point is the point at which a function attains its maximum value. Why minimum point is the point at which a function attains its minimum value. So now, how do we differentiate clearly between these two terms? That is, how do we differentiate clearly between extremum values and extremum points? So now, let's suppose we have a function f of x to be equal to 2x squared minus 1, and we have its domain to be 1, 2, 3, 4. Yes, we can call this the domain of this function. Why? Because this set satisfies this function, because we can evaluate this function at every point in this set. So now, let's evaluate this function at every point in this set by doing so one by one. Evaluating this function at the point where x equals to 1, we have the function to be f of 1 equals to 2 into bracket 1 squared minus 1, and the evaluation leads to 1. Evaluating the function at the point where x equals to 2, we have this to be 2 into bracket 2 squared minus 1, and this will give us 7. Evaluating the function at the point where x equals to 3, we have this to be 2 into bracket 3 squared minus 1, and this will give us 17. Evaluating the function at the point where x equals to 4, we have this to be 2 into bracket 4 squared minus 1, and this will give us 31. So now, what is the maximum value of this function in its domain? The maximum value of this function in its domain is what? Is 31. And the minimum value of this function in its domain is 1. So what is the maximum point now? The maximum point is 4, because 4 is the point at which the function attains its maximum value. So the maximum point is 4, the maximum value is 31. The minimum value here, the minimum point here is 1, and the minimum value here is also 1, because 1 is the point at which the function attains its minimum value in its what? In its domain. So now, since we understand the difference between these terms, we need to take the proper definition of the extremum points. We are to talk about the definition of the extremum values and points of a function. So now we start with the relative maximum value of a function, and we also talk about the global maximum value of a function. There's a little bit difference between the two, between relative maximum value and the global maximum value. So also there's a difference between a relative minimum value and a global minimum value. So now let's see the difference and let's look at the definition. A function, now we are talking about the relative maximum value. A function f is said to have a relative maximum value at point x equals to c if the value of the function at s equals to c is greater than its value at all points close to c. That is, a function f is said to have a relative maximum value at the point s equals to c if the evaluation of the function at f equals to c is greater than the evaluation of the function at the points, at every point closer to c. Then we say that the function has a relative maximum value. Why? Because we are not considering every point in the domain. We only consider the points closer to c. We compare the evaluation of the function at the point x equals to c with the evaluation of the function at the point closer to c. So if the evaluation of the function at the point x equals to c is greater than the evaluation of the function at the point closer to c, then we say that the function has a relative maximum value. So now, let's talk about the global maximum value. A function f is said to have a global maximum value at a point s equals to c if the value of the function at s equals to c is greater than all other values of f in the domain of f. So now, a function f is said to have a global maximum value at the point s equals to c if the value of the function at the point s equals to c is greater than the value of the function at every other point in the domain of the function, then we say that the function has the global maximum value, that is the highest maximum value in the domain. But remember that in the relative maximum value, we didn't consider the entire domain. We only consider points closer to the point C. So now let's talk about the relative minimum value. A function f is said to have a relative minimum value at point s equals to c if the value of the function at s equals to c is less than its value at all points close to c. What is the difference between these? They are almost very similar, but the difference is just that instead of greater than here, we have less than. So now a function f is said to have a relative minimum value at point s equals to c if the value of f at the point s equals to c is lesser than the value of f at the point closer to c. Then we say that f has a relative minimum value. So also a function f is said to have a global minimum value at a point s equals to c if the value of the function at x equals to c is less than all other values of the function at all other points in the domain of f. Now, a function f is said to have a global minimum value at the point s equals to c if the value of the function at the point s equals to c is lesser than the value of the function at all other points in the domain of f, then we say that the function has the global minimum value. It has the global minimum value. It has the global minimum value at the point x equals to c. So now let's put this graph over here. Let's assume the graph to be the graph of an arbitrary function f of x. Notice that the graph of a function helps us to view the pattern and the features of a function. So now let's assume that this graph is the graph of an arbitrary function. The points A, B, and C are called the relative maximum value. Why? Because there is another point D which is greater than the points A, B, and C. And the point D is called the global maximum value. Because in the domain of the function, the domain of the function is the x-axis. At every point on the x-axis, there is no point at which you will evaluate the function that will be as high as d. It is only at the point, let's say the point C. It is only at the point C that the function will have the highest value. And the point at which the function will have the highest value, which is c, is d. The value of the function at point s equals to c is d, which is the highest value of the function. These points A, B, and C are called the relative maximum points. Yes, they are the relative maximum because when we consider these points, now we can consider the evaluation of these points. Let's call this place x naught. When I evaluate the function at the point x equals to x naught, I have the value to the c. If we consider the point closer to x naught, we are not considering the entire domain now. We are considering the point closer to x naught. The evaluation of the point closer to x naught will not be as high. As the evaluation of the function at the point x equals to x naught. The evaluation of the function at the point x equals to x naught will have the highest value. It will be higher than the evaluation of the point closer to x naught. If you evaluate the function at the point closer to x naught, there will be somewhere at this place. There will never be as high as c. It is only at the point s equals to x naught that you have the highest value. That is why we call c the relative maximum point. The same thing applies to B and the same thing applies to the point A. So, but the point B is the global because for the evaluation at the point S equals to C is greater than every other evaluation of the point in the domain. So also the points H, F, and E are called the relative minimum points. Why? Because when we think of H, the value of H, F, and E are differ. They differ in value. So now the global minimum value of the function is G, because G has the lowest value in the entire domain. It has the lowest value in the entire domain. If you consider this point to be the point C, the evaluation of the function at the point C gave us G, and G is the lowest value. So every other evaluation of the function is not as low as G. G is only the lowest value. So every other evaluation of the function at every other point in the domain of X is not as low as G. So G is called the global minimum value, while H, F, and E are called the relative minimum value, because for H we will only consider the points closer to the point of evaluation. If we call this point the point C here, the point closer to the point C, we never have the value as lesser as G. It is only at the point C that we have a lesser value. Point closer to point C, we never have a value as less as the value of the function at the point S equals to C. So that is why H is also a minimum value, but H is a type of minimum value that is called relative minimum value. So now, after we have looked at the definition of the extremum values and points of a function, it's time for us to look at some examples under extremum values and extremum points of a function. We shall consider some examples to find the extremum values and extremum points of a function. But from the graph, notice that the extremum values of a function happen at the turning point. For instance, this is an extremum value. Every point marked on this graph, they are the extremum values, because we said extremum values are either the maximum values or the minimum value. And the extremum values happens at turning points. Look at this, is a turning point, this is a turning point, 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 and also a turning point. Here also a turning point. So the extremum values of a function happen at the turning point. And the turning point also is also referred to as the stationary point or the critical point. It is the stationary point or critical point because it is the point at which the gradient function of f of s is equals to 0. Yes, because it is the point at which the gradient function of a function f of s equals 0. Because the gradient function of this function at this point will be 0, because when you draw a tangent to this point, it will be horizontal, and the gradient of any horizontal line is 0. So that is why we are going to set the gradient function to be equal to 0, and that indicates the turning point of a function. So let's look at some examples of solving extremum values and extremum points of a function. So now, here are some examples. We have that find all extremum points of the function y equals to x squared minus 1, and b y equals to 2 plus 3x minus s cubed. So now we start with the first one, which is y equals to x squared minus x. Notice that I said to you that the extremum point of a function or the extremum value of a function happens at the turning point. The extremum value of a function happens at the turning point. And at the turning point of a function, the gradient function of that function is what? Is 0. The gradient function of a function at a turning point is 0. So that means we have to differentiate this function and set the differentiation and set the gradient function, which is the differentiation. We are now going to set it to be equal to 0. Then we solve for x to get the extremum point. So now, differentiating this function, y, we call this y prime, or we write it as f prime of x. And differentiating this, we have it to be Using the rule for polynomial, we have this to be 2x minus 1. So now we have that our f prime of x now is what 2x minus 1. But which is the gradient function? We call this the gradient function of the function f of x. F prime of x is the gradient function of the function f of x, and at the turning point the gradient function of the function is equal to 0, and we have the extremum value of the function at the turning point. So we have to set this f prime of x to be equal to 0 now. So now by setting f prime of x to be equal to 0, we have that 2x minus 1 equals to 0 and 2x equals to 1, and solving for x, we have that x equals to 1 over 2. Yes, this is the extremum point. This is the extremum point of the function, because this function will have either its maximum value or its minimum value at the point where x equals to 1 over 2. But now we don't know if the extremum point is a maximum point or a minimum point. Remember that extremum point is either maximum point or minimum point. So we need to know if this 1 over 2 is a maximum point or a minimum point. So how do we know if it is? We have to find two numbers such that 1 over 2 lies between the two numbers. What are the two numbers? The two numbers are 0 and 1, because 1 over 2 lies in between 0 and 1. So now the original function, which is y equals to x squared minus x, that is y equals to f of x, and the f of x is what? X squared minus x. This is the function. After considering the interval 0 and 1, considering the interval 0 and 1. Yes, why do we consider the interval 0 and 1? Because 1 over 2 lies in between 0 and 1. So following the definition of maximum, relative maximum, we want to see if the evaluation of the function at 1 over 2, if it is greater or lesser than the evaluation of the function at the point 0 and 1. So now let's see. Let's evaluate from the function. We have that f of x equals to x squared minus x, right? So now we have to evaluate the function at the point s equals to 1 over 2. So f of 1 over 2 will give us 1 over 2 squared minus 1 over 2, which is 1 over 4 minus 1 over 2. And finding the SCM here, we have this to be 4, which is 1 minus 2, and this is minus 1 over 4. Yes. So now we now evaluate the function at the point s equals to 0. We have f of 0, and this is 0 squared minus 0, and this is what? 0. Evaluating the function at the point s equals to 1, we have it to be 1 squared minus 1, and this is also 0. So now we notice that the evaluation of the function at the point s equals to 1 over 2, the evaluation of the function is lesser than the evaluation of the function at the points closer to 1 over 2. What are the points closer to 1 over 2? 0 and 1. So now, minus 1 over 2 is lesser than 0 and 0. That means the point x equals to 1 over 2 is a minimum point. So now, since f of 1 over 2 is lesser than f of 0 and f of 1, then the point s equals to 1 over 2 is a minimum point. Yeah, so that is all for question 1. We are told to find the extremum point of the function y equals to x squared minus x, and the extremum point is simply 1 over 2. But we want to know if the extremum point is the maximum point or a minimum point. So by knowing if it's the maximum point or minimum point, you are going to consider an interval, but the interval must contain the point 1 over 2. 1 over 2 must lie in between the end interval, that is the end interval 0 and 1. So 1 over 2 lies in between 0 and 1. That is why we consider this interval. So now we evaluate the point s equals to 1 over 2 and the end points in the function to compare them and know the one that is lesser or greater. By doing so, we have that the evaluation of the function at s equals to 1 over 2 is lesser than the evaluation of the end point. Since it is lesser from the definition of relative maximum, then it follows that s equals to 1 over 2, which is the c, is a minimum point. So now let's consider the second example. The second example states that y, which is b, y equals to 2 plus 3x minus x cubed. So now here also we have to differentiate the function. Then we have y prime, which is the same thing as f prime of x, and by doing so, differentiating this constant, we have it to be 0. Differentiating 3x, we have it to be 3. Differentiating minus 3x squared, we have this minus s cubed, we have this to be minus 3x squared. So now, since we know that the gradient function of a function at the stationary point is 0, so we are going to set this gradient function to be equal to 0. That is, setting f prime of x to be equal to 0, then we have this to be 3 minus 3x squared equals to 0. So now, we can factor out 3 from this, and this will be 3 into bracket 1 minus x squared equals to 0. And dividing both sides by 3, we have this to be 1 minus x squared equals to 0. Then, from here, we can, this is difference of 2 squared, yes, difference of 2 squared, or we can simply say this is x squared equals to what? Equals to 1. Because by taking x squared to the other side, we have this to be x squared equals to 1. Taking the square root of both sides, we have that s is equal to plus or minus 1. Because taking the square root of 1, we have the answer to be plus or minus 1. So the extremum point of the function y equals to 2 plus 3x minus s cubed, the extremum points are 1 and minus 1. So now we have known the extremum point. It's now for us to know if the extremum point are maximum point or minimum point. So now, from here, we now consider an interval. We consider an interval. We want to consider the first point, which is 1. So we consider an interval that is containing 1. Which interval is containing 1? We have 0 and 2. So we consider the interval, considering the interval 0, 2. Yes, because 1 lies in between 0 and 2. That is why we consider this. So now, the function given to us, which is f of x, is 2 plus 3x minus s cubed. So evaluating this function at s equals to 1, that is f of 1, we have this to be 2 plus 3 into bracket 1 minus 1 cubed. And this is 2 plus 3 minus 1, right? So this is simply 4. So now, evaluating the function at s equals to 0, we have f of 0 to be 2 plus 3 into bracket 0 minus 0 cubed. So now this is simply 0 minus 0, 0, and this is 2. Evaluating the function at the point s equals to 2, we have this to be 2 plus 3 into bracket 2 minus 2 cubed, right? And this is 2 plus 6. 2 raised to power 3 is simply 8. This is minus 8, right? And evaluating this, we have this to be 0. 2 plus 6 is 8 and 8 minus 8 is 0. So now, we can now see that the evaluation of the function at the extremum point, which is s equals to 1, it is greater than the evaluation of the function at 0 and 2. So 4 is greater than 0 and 4 is greater than 2. So the evaluation of the function at the point s equals to 1 is greater than the evaluation of the function at 0 and 2. So hence, the point s equals to 1 is a maximum point. It is called a maximum point. So now, it's time for us to know if the other point, which is minus 1, if it is also a maximum point or a minimum point. So now, let's do that. So now, we have that we consider an interval containing minus 1. Which interval is containing minus 1? We have the interval of minus 2 and 0. Yes. Considering the interval minus 2 and 0, we have that. Remember that minus 2 and 0, minus 1 lie in between minus 2 and 0. So that is why we are considering this interval now. So now we have to evaluate the function at the point s equals to minus 1. So now the f of x given to us is simply 2 plus 3x minus s cubed. So now f of minus 1 will be 2 plus 3 into bracket minus 1 minus minus 1 cubed. And this is 2 minus 3. Minus 1 raised to power 3 is minus 1, and minus times minus will be plus. So 2 plus 1 is 3, and 3 minus 3 is 0. So now, we now evaluate the function at the point s equals to minus 2. So this will now be f of minus 2, which is 2 plus 3 into bracket minus 2 minus minus 2 all raised to power 3. And this is 2 plus 3 times minus 2 is minus 6. And minus 2 raised to power 3 is minus 8. Minus 8 times minus is plus 8. And this is plus 8. So now, 2 plus 8 is 10. And 10 minus 6 is what? Is 4. So that's the evaluation of the function at the point x equals to minus 2. So we evaluate the function at the point s equals to 0 as well. So we have to be f of 0, which is 2 plus 3 into bracket 0, right? Minus 0 raised to power 3. And this is 2 plus 0 minus 0, and this is what? And this is 2. So now we have that the evaluation of the function at the point s equals to minus 1. We have that the evaluation is less. It is less than 4 and it is less than 2. That means the evaluation of the function at the point s equals to minus 1 is lesser than the evaluation of the function at the point s equals to minus 2, and it is lesser than the function at the point s equals to 0. So since it is lesser, hence the point s equals to minus 1 is a minimum point. Yeah, so that is the answer and the solution for the second question. And here comes the end of the class. Though we still have some other subtopics to treat under this topic, and the video will be released later. Please subscribe to my YouTube channel, like the video, and please share across. Don't forget to click on the notification bell as well. And if you have any question concerning the class, you can please drop in the comment box below. I'll see you in my next video.